Again, everyone, kindly record your attendance in the LMS. Okay, 1A, I think my connection is not so good right now. Can someone help me in sharing the presentation? Kasi nagamit og laptop or desktop computer. Okay, kasi maka-share sa presentation. Si Karil. Karil, nara sa kuan, first quarter LMS. Kanang face changes. Yes, please. Thank you, Karil. Okay, 1A, wala na tayo exam sa chemistry. So mag-experiment rata this coming Thursday. So please wear your lab gown, bring your lab gown with you and your gloves. Katong surgical gloves ha, dili ka ng pang gardening. Okay, na gloves. Again, we'll be having our laboratory activity this coming Thursday. And by next week, so by Tuesday, sa schedule sa inyong chemistry na exam, ipas ang laboratory worksheet. Okay? Again, karong Thursday, mag-laboratory ta, experiment. By Tuesday, wala na tayo exam, but inyong ipas ang worksheet ninyo. Okay? 1A? Saka na ara siya, everyone. Okay, thank you so much, Karil. Yes. So I think this lesson, you have already encountered this one in your Chem 1 or maybe in junior high school. So this is so easy lesson. Next week, we'll still discuss phase changes, but we'll use phase diagrams. Okay. To understand more about the diagrams, let's review first. Let's recall the different phase changes, examples of phase changes, and what happens to the molecules and the heat energy in phase changes. So before we proceed to our lesson proper, let me inform you our learning competency. Yes, next slide please, Karine. Okay, so the main focus of this lesson is for you to be able to describe the nature of the following phase changes in terms of energy change and the increase, let me admit first your classmates, and the increase or decrease in molecular order, solid, liquid, liquid to vapor, and solid to vapor, or solid to gas. Okay, let's start now our short activity, no? Let's have the next slide, Karil. Okay, look at the first picture. Describe the following phase changes that occur in matter. Okay, what kind of phase change is it?
Melting.
Okay, yes, Andre. You can raise your virtual hand if you want to answer. Yes, Andre, what's your answer?
Melting, ma'am. From solid to liquid.
Okay, very well said, Andre. So it's melting from solid to liquid. Okay, let's have the next picture. Yes, what about this one? Yeah. Axel, go ahead.
Evaporation, no?
Evaporation, what does it mean?
From liquid to gases.
Okay, very good. Thank you, Axel. Next picture. Yes. How about the others? Let's have Angel Denise Lopez.
It's solid to gas, ma'am. Sublimation, ma'am.
Okay, very good, Angel. That's sublimation, solid to gas. Okay, next. Okay, this is moist. No, or moisture. Yes, Robert.
Condensation, ma'am, from gas to liquid.
Oh, I'm sorry, Robert. I cannot hear you very well. I think someone
Condensation,
nag-ayong
ma'am.
diri. Okay, very good. Condensation. So condensation from gas to liquid. Okay, next one, please. Okay, this is from liquid to solid. Liquid to solid. What do you call that process? Okay, liquid to solid. Yes, si Crizel. Freezing. Okay, very good. Morning twins, no? Si Karil and Crizel.
Yes, ma'am.
Okay. Alright, so we're done with our activity. Let's start now our lesson proper. So sayo na kayo niya siya, no? Dalira kayo. Our next activity, laboratory activity, that will be related to phase changes. So next week, by exam man siya, di ba? So we'll have another laboratory activity. But we'll discuss first katong phase diagram. Okay? And then laboratory activity which is related to phase changes. Okay, so what is a phase change? Let's have the next slide. Okay, when we say phase change, that's the transformation of matter from one phase to another. So it's a process, no? Wherein one state of matter changes into another state or ni-transform siya into another state. So since may changes, so there are factors that are involved in its changes. So it always involves absorption and release of heat. Okay, so we have here some examples, no? Like heating of salt solution. So what kind of phase change happened in this picture? So during a phase change again, heat energy is either absorbed or released. Heat energy is released. Okay, for a moment. So heat energy is released as molecules slow down and move closer together, while heat energy is absorbed as molecules speed up and expand. So in this picture, what happens to the heat energy? Is it being absorbed or released? So we're heating salt solution. So what happens to the heat energy here? They absorb or they release or remove sa matter or sa molecules. Okay, if it involves heat energy, so heat energy there is absorbed. Just like for example, heating salt solution. Okay? Now what happens to the speed of the molecules? Remember, if we're going to increase the temperature, the kinetic energy will also increase. So that means the molecules will speed up. They will move very fast. And aside from that, since ni-undergo man siya og heat, so the molecules will also expand. Okay? From liquid, it can change into vapor or gas. On the other hand, if we're going to remove heat, everyone, the heat energy there is being released. No, the molecules will move slower. They will move slowly. Okay, they will move closer together. Okay, let's have some examples, no, wherein the heat energy is being absorbed. Okay, what kind of phase change? Let's have the next slide. Okay, we have melting. So when we say melting, it's a phase change from a solid to a liquid. So here, we apply heat energy. We increase the temperature. Now, since we increase the temperature, molecules speed up. They move further apart and they absorb heat energy. So for example, solid, na-change siya into liquid through the process of melting. Okay, more examples of melting. We have the next slide. Melting of ice cream, melting of candles. And we also have here melting of butter. Like in cooking, instead of using oil, we can also use butter. No, but we need to melt first the butter. So how do we melt it? Of course, we need to apply heat. So that's melting. Next phase change, we have another one, evaporation or vaporization. So vaporization, it's a phase change from liquid to a gas on the surface of a liquid. Okay, molecules here, they speed up, they move further apart, and absorb heat energy. So sa melting, from solid to liquid, okay, we heat the solid to change its form or to transform it into liquid phase. So what about if si liquid na sad ang atong initon? So what will happen to the liquid phase? So this will eventually change to gas phase. Okay? So, through the process of evaporation or vaporization. So, we increase the temperature. So, for example, for water, if ang temperature niya ni-reach na into 100 degrees Celsius, which is the boiling point of the water. So, the liquid particles will also escape from their liquid phase and they will enter the gas phase. So, from liquid to gas, that's evaporation. Now, since nag-apply man tag-heat, the molecules again, they speed up, they move further apart as they absorb heat energy. Okay? Everything that undergoes heat, they expand. No? So, if ang usa ka matter, imo siyang initon, ang molecules niya mo expand siya. So, that's why kanaganing Eiffel Tower sa France, everyone, mas taas siya or mas taas siya kung summer. Kay init man ang summer, di ba? So the temperature is very high. Again, if ang matter ni undergo siya og heat, mo expand ang iyang molecules. So mas taas ang Eiffel Tower during summer compared to other seasons. No? Same goes with other objects or matter. If naa siya'y application of heat, mo expand ang iyang molecules. Okay, let's have more examples of evaporation or vaporization. Like drying of clothes. So, igong magpanglaba, i-hide-hide. Then later on, mauga na, no? So, the main reason why the clothes become dry, it's because of evaporation of this phase change. Ang liquid, na-change siya into gas. Ang liquid, which is the water, na-change siya into water vapor. Another example, we also have alcohol or boiling of water. So these are common examples of evaporation or vaporization. All right, so let's have the next phase change. We have condensation. Okay, so condensation, it's a phase change from a gas to a liquid. So what about here? Kung sa melting, sa evaporation, nag-add ta og heat energy. What about sa condensation? What do we do with the heat energy? What happens to the temperature here? Sa condensation. Again, sa condensation, we remove or we release heat energy. Okay, for example, we have here a gas or a water vapor. Now, if ang gas na-expose siya in cooler surroundings or cooler areas, ma-change siya into liquid. Yes, we need to lower the heat energy. We need to release, we need to remove the heat energy. We need to drop down the temperature para ma-change ang gas to liquid. So, since we remove heat energy, so the molecules of the matter, they tend to move slowly, okay? The molecules, they move slower, they move closer together, and they release heat energy. Okay, for example, we have, next slide please, Karin. Okay, look at the first picture. Now, for example, you like drinking cold water, no? And then you put the glass of water on the table. So in your room, So at room temperature, look at the glass of water. Lalo siya yung mga moist, no, sa glass. So what's the science behind this phenomenon? Or how can we explain it? Asa manigikan ang kaning moist niya? Sa sulod sa glass or asa siya gikan? Everyone, who can explain it? Anong naman siya yung moist? Just like sa windows, no? Anong mag-moist man? Okay, anyone? Let's start with the first picture, no? Sa glass. Ganong naa siya yung moist. Like, water drops sa iyang glass. Asa man nagikan? For example, you place cold water in the glass. And then you put the glass in your room, no? At room temperature. Now, later on, nakabantay ka nga na siya yung mga moist sa glass, gawas niya. Anong na may moist? Like, kanang mga water droplets or water drops. Yeah, what's the science behind it? Or how will you explain it? STEM students. Okay, so picture, no, first picture. Who would like to try? Just try, everyone. Who would like to try? Kaning mga 1A, mga babaon na taning 1A, yung nonson. 1A, asa naman yung pagkabaon, 1A? Yeah, Danica. Okay, just try, no? Asa man dapit dira ang condensation? Yes, Axel. Axel, can you turn on your microphone? Axel, can you turn on your microphone?
Ma'am.
Yes, okay. Go ahead, Axel.
Think na ko mo is kuan ka ng liquid man siya and then tungod sa temperature kay makahiyo siya gas and then tungod sa yung gas is kuan ka ng to gana. Tungod sa gas is kanang ma-contain man siya sa kanang container ma'am and then mo na siya mo reason nganong mo to gana. May murag bubbles or something.
Okay, thank you so much, Axel. So Axel has an idea. No, so remember, ang sulod sa glass, you put cold water in it. Okay? Now, ang glass, imong gibutang siya sa imong room. Nya, ang imong room, ang iyong temperature is maybe 23 to 30, no, 20 to 25 degrees Celsius. So that's the room temperature. Now remember that the water is very cold. So ang katong air nga naa sa imong room, as it reaches closer to the glass, mahimo siyang liquid. Okay? It's because it has cooler temperature. So remember, if ang gas ma-expose siya in cooler area or cooler surrounding, ma-change siya into liquid. Okay? So here, we decrease or we remove the heat energy. We drop down the temperature. Okay, same goes with kanang mga moist nga naa sa windows or sa plants kanang dew drops niya. Okay? Those are examples of condensation. All right, let's have another phase change example. We have freezing. So this is a very common phase change. That means from liquid to solid. So for freezing, we also remove heat energy. Okay? So from liquid, na-change siya into solid. So molecules here, they slow down, they move closer together, and they release heat energy. Okay, so kung gas siya and na-expose siya in cooler area, so ma-change siya into liquid. What about si liquid? Ma-expose siya into cooler area. no? Like we remove heat energy, like ato siyang gibutang sa freezer. So what will happen to the water or the liquid substance? Ma-frozen siya, okay? Mo-freeze siya. So liquid to solid, that's freezing. We have here examples of freezing, like making of ice, making of ice cream. Look at the last picture. Ano man ang last picture? Color yellow. Ano man na siya? Yeah. It's oil, okay? So last picture, that's an oil. So in some other countries, their climate, no, they have very cold climate. Maunang ang uban nilang butang or substances, no, makuan siya, ma-frozen siya, just like aning oil. It's a frozen oil. So na-freeze siya. It's because of the very cold climate they have. Okay, next phase change, please. So we have here deposition. So it's a phase change from solid to gas. Okay, so molecules here, they speed up, they move further apart, and they absorb heat energy. Okay, for example, we have here, so we also apply heat energy, we add heat energy. Okay, next daw, next daw. Next budget. Sa'yo pa ni siya, oy. Next budget Karil. Yeah, gas to solid siya. Okay, gas to solid, that's deposition. Solid to gas, that's sublimation. Okay, I think this is typo. Yan, balik, backward Karil. Okay. Okay, diri lang. So, phase change from solid to gas, that's sublimation. Okay? So, we have here an example. We also add heat energy here. So, since we add heat energy, the molecules here, they speed up and they move further apart. For example, dry ice. So, what is dry ice, everyone? Is it the same with the ice that we have at home? Like ice water. Pareha
No,
na ba
ma'am,
na
it's
sila? Yes, Robert. What is this made of?
made of frozen carbon dioxide.
Very good. So this is a frozen carbon dioxide. So remember, in our previous discussion, we talked about solids, different types of solid. No, si carbon dioxide, pwede siya crystalline solid. Okay? In its solid form, the common name is dry ice. But at room temperature, carbon dioxide is a gas. But again, if we're going to remove heat energy, pwede siya ma-change into solid. So we call it dry ice. So it's a frozen carbon dioxide. Now, for example, you get the dry ice and put it at room temperature. So in the place with room temperature, like 20 to 25 degrees Celsius. Now, what will happen to the dry ice? So, that will change from solid to gas. So, it will go back to its gas phase. Same goes with other objects like naphthalene balls. So, they were commonly used before by many people. So, we put it in the drawers or cabinets para to get rid of the insects, no? Kanang naphthalene bowls. I don't think na this is still common nowadays. But that's an example of sublimation. Okay, let's have the next slide. We have here deposition. So deposition, that's from gas to solid. Okay, now uh, if there is like an extreme drop down of the temperature, like we remove heat, a lot of heat energy, no? Like below pa siya or mas ubos sa freezing point, the gas can change into solid. without passing the liquid phase. So remember, no, ang gas is if ma-expose siya in cooler areas, mo condense siya, meaning ma-change siya into liquid. But if grabe ka cold ang iyang temperature, everyone, like mas bugnaw pa siya or mas gamay pa siya sa freezing point, so that means ang gas, pwede siya ma-change directly into solid without passing the liquid phase. We call that process deposition. So the molecules here, they slow down, they move closer together, and they release heat energy. For example, we have frost. And we also have another one, that's an active volcano. So ang active volcano, ni-release siya o gases. And these gases, they are also made of sulfur. At room temperature, ang sulfur kay solid siya. Okay? When it reaches cooler area, ang kaning nga gas, ma-change siya into solid. So these are sulfur deposits. Okay? The process, we call it deposition. The last picture, that's also made of salt and mineral deposits. So they come from the air, and then uh, and if ma-expose siya sa cooler na surrounding, so mauna maka-form siya og ingana, no? So that's salt and mineral deposits. Okay, we call this process deposition. Okay, next slide, Karil. Okay, so we have here the summary: melting, evaporation, sublimation, condensation, freezing, and deposition. For melting, in order to change the solid phase of the matter into liquid, we need to add heat energy. Evaporation, liquid to gas, still add heat energy. Sublimation, solid to gas. So we need to add heat energy. For condensation, freezing, and deposition, we need to remove heat energy for these processes to occur. Okay? Para ma-change ang gas to liquid, kailangan mag-remove ta og heat energy. Same goes with liquid to solid and gas to solid. Okay, next slide please, Karil. Okay, we have here, so same lang na siya, no, phase changes of matter. Sublimation, energy is added. Evaporation, energy is added. Condensation, freezing, and deposition, energy is removed. Okay, next slide. So check the LMS for the next laboratory activity. Print or copy it in a short bond paper. Bring your lab gown and surgical gloves next meeting. Next slide, Karil. Okay, let me inform you first. Let me give some instructions about your laboratory activity. Okay, thank you so much for sharing, Karil. Thank you for helping me in sharing the presentation. Okay, let me share my screen, everyone. Katong laboratory worksheet na to, katong working with beam balance, ipass to siya this coming Thursday. Okay? Mayor, ay wala mo may mayor no, si Rubio. I think Rubio, ikaw ang na-assign sa karong Thursday? Ni Brand at
Opo, ma'am.
ikaw. Okay, si Rubio. Okay, kindly pass your worksheet on Thursday to Rubio. Okay? And make sure to attach the evaluation sheet. Let me share this one first.
Ma'am.
Yes,
Sa kuan
Axel.
lang ba, sa worksheet ma'am ba kay apilan patog send, ay apilan patog butang ang picture.
Picture? Hala, wala ko. Ayaw po di picture, everyone. Drawing nga. Okay? Asa drawingon sa katong right na column. Diba? Gamay ra kay ang space. So, gamay ra sad ang drawing. Pwede
Okay
ra
ma'am,
dili
thank you.
kuluran. Okay? Basta na ay label. Okay, wait sa kay nag-open pa ko sa file. Makagwapa lagi diri nga site. Pila ko, fresh kay ko diri. Dealer. Okay, let me share my screen. Okay, at exactly 11 a.m. this coming Thursday, so group leaders, you will go directly to chemistry laboratory and then ask for a borrower slip from the working student. Then you're going to write all the apparatus needed in your activity and the materials as well. Okay, write your name, leaders, and give your ID to the working student. So remember natin 8 ka table sa Chem Lab. So dapat 8 ka grupo. Okay? So here are the main objectives. That's for you to identify if it's polar and non-polar or identify appropriate solvents to dissolve solutes. So supposedly, before the last week pata di siya, no? But again, we were busy with the science one. But this is related to your previous lesson. Okay, so again, leaders, please take note at 11 a.m. kailangan nakabaro na og mga apparatus. So here are the different apparatus needed. 9 ka test tube. Okay, so you need to write there test tubes. Sa under sa quantity, you write 9. Usa ka test tube rack, kanang butanganan sa test tube. Duha ka test tube brush. Kaila ra ang mga working student ani. Duha ka graduated cylinder and usa ka beam balance. Now since upat ra man atong beam balance, so for example group 1 you will share your beam balance with group 2. Yeah, 3 share your beam balance with group 4. Okay? And for materials, you need to use sodium fluoride. So just ask all of these from the working student. So sodium fluoride, potassium nitrate. So this is still salt, no? Another form of a salt. Ethyl alcohol or ethanol. And we also have kerosene. So this is we commonly use it as a fuel, no, sa lamp or kanang lampara. So a fuel in cooking. So we use kerosene. And then water, you can get water from the CR since wala tayo water sa laboratory. Glycerin or glycerol, this is another form of alcohol, but this is a sweet alcohol. So please do not taste any of these substances. Okay, some of them are flammable. So please, ayaw, ilawi everyone. Okay, please also wear your surgical gloves if you have. If you do not have, then it's okay. Okay, so read and understand the procedure. Now, you need to wash the test tube and the graduated cylinder before and after using it. So secure 3 test tubes and place 5 ml of following solvents. So i-measure sa daan 1A. Okay? Measure 5 ml of water. Next, ethyl alcohol 5 ml. 5 ml of acetone. Okay, you need to use graduated cylinder for this to get the volume. Okay, 5 ml. Now, ang water, ethyl alcohol, and acetone, pari-pareha naman na sila og color, di ba? So, maglibog mo. Asa man ani nga test tube ang ethyl alcohol or acetone. So, you need to label it. So, kabantay mo sa table, sa Chem Lab, kanang tiles siya, di ba? So, I think pwede ra mo makasuwat, but katong whiteboard marker, ma-erase ra man na siya. Dili lang dakpon sad ang label. Okay, for example, first test tube, water. Okay, suwat dito. Gamit ang whiteboard marker. I-erase lang sad later. Second test tube, ethyl alcohol. Third, acetone. Now, once you're done, everyone, you will use these substances as your solvent. Okay? Meaning, mas taas iyang or mas dako iyang quantity compared to the solute. So we will use sodium chloride as our solute. So measure the sodium chloride, make sure that they are all in 0.55 grams. So you need to use the beam balance here. Okay, dapat 0.5 grams. Then put the 0.5 grams of sodium chloride in water alcohol, and acetone. Now, shake the mixture very well. So, in shaking everyone, just move it sideways, no? Dili siya dapat i-steer. Shake lang dapat. And then, record your observation. So, you're going to write there, you draw the three test tubes here. Water, ethyl alcohol, acetone, no? And then, record your observation. Sodium chloride is most soluble in water. Partially soluble in acetone, least soluble in ethyl alcohol. So, ingana ang buhaton, okay? Diri nga part. Drawing ang tulo ka test tube, label, and your observation. Okay, next we have so repeat procedures 1 and 2. Same ra ang procedure. Ang ato rang giilisan kay ang iyang solute. This time we're using potassium nitrate. And same ra gyud tanan no, 0.5 grams. So i-mix siya, shake, and record your observation. Okay, last one, we have the miscibility of these substances. We have oil, kerosene, and glycerin in water. So measure them. Kindly use the graduated cylinder and make sure that they are all in 2 ml. Their volume is 2 ml. Okay, every after the substance, everyone, you need to wash the graduated cylinder para dili mo contaminate siya. Okay? Ma-mix na ang oil o kerosene if dili nimo hugasan ang graduated cylinder. So again, kindly wash the graduated cylinder. You can also use the test tube brush in washing. Okay, again, you need to measure these substances, oil, kerosene, and glycerin. And mix it with water. Record your observation. Miscible ba siya? Ma-mix ba siya? Or immiscible? Dili ba ma-mix? You need to pass this one on Tuesday. Okay? The day sa inyong exam. So wala na mo buhaton nga exam, igura mo mag-pass ani nga activity. So please print or copy this one as well in a short bond paper. Evaluation sheet. Inigpas ninyo sa laboratory activity number 1, dapat naka-attach ang evaluation sheet. Because I'll be writing your scores here and you will be graded based from these rubrics. Preparation and punctuality, 10 points. Manipulation and safety measures, 10 points. Efficiency and accuracy, 10 points. Cooperation and aftercare, 10 points. Observation and inferences, 10 points. So total, 50 points. So you write here, number 1, working with beam balances. You write your name as well. Ayaw lang siya staple. Kaya inigpas ninyo sa laboratory activity number evaluation sheet. I-clip lang siya. Okay? 1A para matangtang radali, no? Okay, questions. 1A. Pangutana? Walay pangutana?
Excuse me, ma'am.
Yes, Karil.
Magdaan pa mi og kuan, ma'am, katong dishwashing something para like
Yes, you need
i-use sa test tube.
Yes, you need to bring that one kay manghugas man mo sa test tube. So abi ninyo sa balay ra mo manghugas og plato sa Chem lab sad. Okay? You need to wash the test tube and the graduated cylinder before and after using it. Okay, another question. Okay, wala na pangutana. Are we good, everyone? 1A?
Yes, ma'am.
Okay, so to those who haven't recorded their attendance yet, kindly record them in the LMS. Thank you so much for your time, 1A, and have a nice day to all of you. So that's the end of today's class, virtual class. See you on Thursday. Thank you and goodbye for now.
Thank you,
Bye,
ma'am.
thank
Goodbye,
you,
ma'am.
ma'am.